Hello everyone, I'm E from the Computational Science Initiative at the Brookhaven National Laboratory. Today, I'm going to present our work on UVCGAN, UNet Vision Transformer Cycle Consistent GAN for unpaired image-to-image translation. As a national lab, we have a call for unpaired image translation because we want to study how the computer simulation of a phenomenon in physics, like the collision of high-energy particles, differs from the recording of a real instance of the phenomenon. We do so because simulations are cheap to obtain, but to make some physics happen and to record it can be super expensive. Different from most image translation tasks, we assume the translation in our case is one-to-one, and hence we have a much higher consistency requirement. And that is why we resorted to a relatively early model called CycleGAN, because although more recent models may produce better outputs, they usually do so either by using a relaxed consistency constraint or introducing extra stochasticity. Here, we show a diagram of CycleGAN. It consists of two pairs of generative adversarial networks, or GANs. The generators do the translation, while the discriminators ensure the translation quality. And to enforce consistency, CycleGAN requires a cyclically translated image to be similar to the original input. The CycleGAN codebase provided two choices for generators, ResNet-based and UNet-based. While the UNet-based generator is inferior to the ResNet-based one on some tasks with natural images, it worked better on our physics-motivated task. Hence, we decided to use the UNet-based generator as the starting point of our design. One problem with UNet is that, as a CNN-based model, it is great at capturing short-range dependencies, but may struggle at modeling long-range ones. So, what would happen if we equipped UNet with something that can handle long-range dependencies, such as the Vision Transformer? This led us to our hybrid generator, a UNet with a Vision Transformer bottleneck that combines the best of both worlds. UNet for modeling local pixel patterns and Vision Transformer for modeling long-range coherence. To see the potential of our cycle-consistent GAN with the UNet VIT generator, we trained it on 3 benchmarking datasets: Anima's selfie translation, Slip A gender swap, and Slip A eyeglasses adding and removal. And we compare UVCGAN with 4 benchmarking algorithms: ACL GAN, Console GAN, Get It, and of course, CycleGAN in terms of FID and KID scores. UVCGAN outperformed the benchmarking algorithms in 4 out of the 6 translations and ranked second in the remaining 2. We also compared model size and training time of UVCGAN with the benchmarking algorithms. We can see that UVCGAN has moderate size and trains fairly fast. To determine what might also help other than innovative generator design, we did an ablation study with 3 factors: whether to pre-train the generators, and if so, on which dataset, whether to use gradient penalty in discriminators, and whether to include identity loss. We found 2 of them, pre-training and gradient penalty, benefits the performance significantly. Finally, this is our team. We also shared complete code with pre-trained models in the 2 GitHub repos listed here. Thank you so much for your attention and enjoy the rest of your day.